Welcome. I'm really excited to have everyone here today, and more importantly, to kind of learn myself from some very smart individuals that we'll be talking with today. What we'll be talking about is the machine learning model specification for the spatiotemporal asset catalogs. I know it's a mouthful, but in short, MLM stack as a common way to understand, share, and distribute information about machine learning models on top of raster data. This is a problem that we'll dive into and understand in greater detail why we need something like this to make it more accessible, and really start to get a handle on how all these things kind of fit together and how you, more importantly, can actually use this in your own work. So that's what we'll do. I'm going to let everyone kind of join here for a minute, give it about 2 more minutes, and then from there, we will go ahead and get kicked off. So while we're waiting, I'd really be curious to hear where everyone is joining in from. And if you have any specific questions, things you're looking to get out of today, please drop that in the chat. You should see like a chat button somewhere down here. Go ahead and open that up. Let me know who you are, where you're from, and any specific questions you have right away, so we can kind of make sure we're addressing those and talking about that as we go through. So. St. John's, Newfoundland. That sounds nice. San Francisco, India, welcome. UK, -16. Oy. Yeah, that'll be cold. If that is Minnesota, I'm heading there in a few days, so I'm prepared for the cold. Seattle, Virginia Beach, Ireland, Rio, France. Welcome everyone. And yeah,
apologies for the delay. I was trying to get in, but getting some update issues. But I'm here now.
All
Hello,
good.
everyone.
Welcome. So yeah, we're just kicking off. Everyone's kind of letting us know we have people from literally all over the world. Copenhagen, Peru, Nairobi, LA. This is great. So I'm glad to see such a group from everywhere. So yeah, I'll introduce myself very briefly, but I'm probably the least important person here today. But I'm Matt Forrest. I head up our customer engineering at Wherobots. So I help create different resources to help learn on top of our platform. And I primarily work a lot with vector data, but I am starting to get more and more into the world of raster data and learning a little bit more about that. But the group here today I'm just here to facilitate this discussion. I'm just going to have everyone quickly do an introduction, and then we'll jump into the kind of the discussion for today. So I'm just going to go in order of who's on my screen, at least on my end, which may not be the same for all the folks presenting. But Francis, would you mind going first, as you are in my upper left corner here? So.
Yes. Hi, so my name is Francis Jacqueminho. I work for the Computer Research Institute of Montreal in Canada. I'm a senior software developer for a few years, and I work mostly on machine learning integration for geospatial platforms. So I will be presenting the STAC MLM spec details.
Great. Ryan, you're up next.
Hey, I'm Ryan. I'm a machine learning engineer at Wherobots. I work mostly on Raster Inference, so a product to help you scale your prediction workloads on Wherobots on top of satellite imagery or drone imagery. I've been working with Francis on the machine learning model extension to STAC, and yeah, super excited to talk to you about that today.
Great. Jed.
Hi, I'm Jed. I'm executive director of Radiant Earth. We're a nonprofit that focuses on supporting this community and helping people find ways to make data easier to access and use. That's included STAC, and it includes this extension as well. Happy to be here.
And Simone.
Yes, hello everyone. My name is Simone Vaccari. I work for Terradue as a EO apps engineer and project manager as well. and I'm supporting customers to integrate their applications into cloud platforms. And I'm bringing in practical examples on how MLM has been used for this.
Great. Okay, so to kick things off, like I said, we're talking about machine learning model specification for spatiotemporal asset catalogs, and we can't get started without talking about STAC, or the spatiotemporal asset catalog, and kind of why it exists, why it's here, all these different things. And Jed, I'd like to start with you to kind of get a sense of, why was this created? Where are we today, and then what's the vision, right? And how does this fit into what we're going to talk about today, from creating a single way to read raster data efficiently?
Sure. Yeah, so let me share my screen. If I can do this right. I've got a few slides. So yeah, let me just, I'll spend a little more time explaining what Radiant Earth does and sort of why we're here, why we're involved in this. Radiant Earth is a nonprofit. We were started in 2016. I became executive director about 2.5 years ago. But when Radiant was first started, the idea was to create a platform that would make raster data easier to access largely for international development projects. And they built a platform to do that. Something, similar to something like Google Earth Engine, like a raster analysis platform, if you can imagine that. But the platform, sadly, didn't really take off, didn't gain a lot of traction. But along the way, we realized there was this amazing community out there of people that were suddenly found themselves with huge volumes of data that were becoming available in the cloud, and trying to just figure out how do we deal with this volume of data that's never really been available to us at this scale because of the cloud. And so today, our stated mission of Radiant Earth is to increase shared understanding of our world through community-led initiatives that make data easier to access and use. That's what we've always done. That's what we feel like there's always need to do that. So that's how we characterize what we do. And so we support a lot of different community-led initiatives. The main kind of flagship initiative that we have for the geospatial community is what we call the Cloud Native Geospatial Forum. And it's a space that we've created. We've got a website, we do events, and we have a conference coming up in the end of April, early May, where we provide a vendor neutral space for people in our community to talk about what's working and what isn't working. The awesome thing about the geospatial community is it's so collaborative and open. We're very lucky to work with a lot of open data, and so people are really, really willing to show off to one another. There's plenty of secret sauce. I mean, we've got a few, there are plenty of commercial companies in our space, and we're happy to have them. But it is a remarkably open and generous community. And so the Cloud Native Geo Forum, we call it CNG, is where we convene those people to talk about what works and what doesn't work. And then STAC is, we are the if you go to the GitHub repo for STAC, it's under Radiant Earth. STAC was created, really, it was kicked off by Chris Holmes. Many of you people might have heard that name. He was a Radiant Earth fellow, and he came up with this concept of STAC to start making sense out of all these massive corpuses of data that were out there, and came up with this very, very simple specification wherein we would just take little JSON files and put them in object stores where spatiotemporal assets are being collected, and make it easy for people to navigate through a huge collection of assets very easily by traversing this catalog, these little JSON files. One way to characterize this, or sort of the need for STAC and how it arose, is that at the time, I had actually worked with Chris Holmes. I was at AWS at the time to bring Landsat data onto AWS, and then we brought on Sentinel, and then suddenly we're like, okay, we have millions of objects in these cloud object stores. Where do we expect people to just list millions of objects every time they want to find anything? That doesn't work. And initially we had a big CSV file that got really big that listed sort of a catalog of everything that was in the Landsat bucket. And STAC is a much more nimble and flexible way of doing things. But this is a way that I would say I give Cholmes all the credit for this, and he's been pretty consistent in a lot of the work that he does, is finding a very, very simple core specification and then allowing it to be extended. And so STAC allows for extensions. It's one of the most, I think, remarkable things about STAC is just how just how much the extension ecosystem has taken off. So, initially Stack was like assuming it's like, yeah, we're just gonna have a bunch of raster data in a bucket. Like, let's make it easy for people to traverse. And people are like, well, are you talking about imagery or are you talking about SAR? What other kind of stuff could we put in here? And the extensions have allowed people to come up with all sorts of metadata specifications that can be a sort of appended to Stack and shared with the community. I will say, Matt asked about what's the future. One of the futures for the Stack ecosystem is getting a little bit better at moderating extensions and figuring out which ones are taking off and have traction and which ones don't, and signaling that better. There is a maturity model for Stack extensions that is being followed. But if you go to stack-extensions.github.io, you can see them all. Now, just one last thing I'll say before I hand it off. Like I said, we like to support community-led initiatives. And what's great about the MLM extension here, the machine learning model extension, is it's very clearly community-led. Like, this is precisely the kind of thing that we like to see, where like multiple institutions that are complementary can come together and cooperate on something and come up with something that works for them and is simple enough, and then will hopefully work for other people. Now, I did just say simple enough in the context of the MLM extension. I think one of the funny things about machine learning models, it's so complicated. There's so much to track and to understand to make a model truly reusable and transferable. And so collecting all this metadata is really difficult. Radiant Earth even tried. There's a model extension that Radiant Earth proposed years ago, and it didn't quite take off. And so, but all that to say is like I'm thrilled, that the community has come together and is having another go at it, and really optimistic about this extension and its prospects given the great people behind it. So more of this to come always. If you want to, go to cloudnativegeo.org and check us out if you want to learn more about our work, convenience community. And I hope I can be forgiven for plugging our conference that we're having in a few months. And so would love to see you all there too, if you're interested. I think some of the people on this podcast or on this webinar will be there, like myself.
Awesome.
So I'll stop there and we can move on, or if people have questions for me, I'm in your hands, Matt.
Yeah. So if there are questions, just drop them in the comments down below. We'll address them, or I'll bring them up as they fit into the flow of the conversation here. But I think it was a perfect, kind of, overview, like in terms of, getting a sense of what Stack looks to accomplish. And it's made a lot of things that I've touched a lot easier, just in terms of searching for data, finding the data, getting the bits I need, and things like that. But of course, it can be a very great vehicle to and to consume and drive a lot more data and use it in really efficient ways. Of course, machine learning is probably one of the most applicable ways for that, especially with, raw imagery. Like, when I say raw imagery, you have multiple bands, you have all the different pieces there. That's one key way to do that. And that part is always something that's, I think the MLM specification really looks to address very poignantly. And that's kind of the next phase. I want to get into that. So I was going to Francis and Ryan just kind of start to give me a sense of what the challenges were. Like, why do we need a specification on top of a specification to provide these things for machine learning models on top of imagery?
Yeah, for sure. I can take that. Yeah, Matt, you kind of hit the nail on the head with Stack. You kind of have this aha moment when you first use a Stack catalog or Stack collection. You're able to search by your area of interest, by your time of interest, by the collection IDs. It's way easier to find the data you need. And that's sort of the experience we want to have for machine learning models too. More and more models are being published every day, every hour, every minute. And it's kind of becoming a flood now where, there's so many models that sometimes do the same things and you don't know how to find them or what geography they were trained on. You want to search on the geography, you want to search on a particular product sensor, like I want models trained on Sentinel or models trained on Landsat. But often these models are not published with the metadata needed to search them. They're also often not published with the metadata needed to run them. Sometimes these models need to be run on specific hardware, like GPUs. And so this is what the MLM is trying to address. It's trying to provide a specification to describe the runtime requirements for the model, as well as all the other characteristics of the model, like how it was trained, what geographic data was used to train it. And so some other like more specific challenges, we've kind of covered that these models have, particular sensor domain, geographic domain, temporal domain. More specifically, these models can also have very specific requirements on the input shape of an image or a multi-dimensional array that you pass in if you're doing like climate forecasts. So those need to be documented and often aren't, even if the model artifacts are shared openly on GitHub or Hugging Face. There can be specific requirements on the input data types for the model or the input data distribution. So thinking about like float 32 versus int 8 data types, all this like very nitty gritty stuff, but it matters to be able to actually run your model in production successfully. And furthermore, like getting into some of the specifics on runtime requirements, models are trained with machine learning frameworks like PyTorch, TensorFlow, and these frameworks have their own specific formats. They often have many formats associated with these frameworks. You might have model checkpoints, which encode kind of the brain of the model, the weights of the model. You might have export formats that are like inference ready, where the model has been optimized to be run on specific hardware. So, it's already becoming quite a maze. And so we kind of need a common language to describe all these framework specific requirements and these data requirements and these input requirements. And that's the core of what the MLM solves.
Yeah, I mean, this is an area that I have not had a much practice in, admittedly. But what I have done is try to infer from, I was looking at wildfire models and, just as a starting point. Looking out there, I found a paper that seemed interesting. It seemed like something that, I could achieve, but it wasn't even clear what I could see broadly the types of data sets were used. And there were a few that pointed to specific data sets. There's like some of the ESA data, things like that. And then other ones that were just kind of like, well, we found this data and it wasn't there. But, there was no, it was very clear that, they had great outputs. The results were amazing. I'm like, I would really like to, try this and do that. But even then, it didn't have all of those little pieces, there's the first hurdles of like finding the data, what features, all those different things. And then even into the data types, you get into like, moving from, is this float 32 versus float 64? These are little things that can just trip up and make the whole process take longer, right? So I think that was like a big realization to me as we were having our initial conversation about this, is just, number one is it can speed up the process, but number two, it can make onboarding and discovery a lot easier too. And I think that's really important. We have a lot of these models out there, and it's just making them easier to find. So that said, like why should someone adopt MLM? Like why should someone use this as the specification? Are there other alternatives out there? And kind of what's the, make the case for MLM Stack in this case?
Yeah, the purpose of it is like really if you have a model that you think is useful and good that you want to share with the world, and you want people to actually use that model when you share it. So there's a lot of models that are published with papers associated with them describing like, cool results they got. And kind of that's the end of the story. Like people look at the table, they look at how the model compares, and then it's kind of too difficult to like run the model or incorporate the model in your workflow. And so you kind of move on to something else. And the goal of the MLM is to, make your model easy for folks to use and consume. And particularly if you're publishing open source models, I think everybody kind of wants their work to, kind of have reach beyond like their own project if they're sharing it. So that is the kind of overarching goal there.
And beyond just, obviously we're talking about geospatial data, and the use cases there, are there other use cases for this specification outside of geospatial? What else could it be used for?
Yeah, totally. So, you know, I'm like kind of a computer vision specialist. I haven't dealt a lot with LLM data, but you know, you can imagine using models that do image captioning and are trained with you know, a component where they can output text to summarize what's in an image. So you can totally use the MLM to describe such a model. It's not constrained to, you know, only describing segmentation models or image classification models. We've tried to make it quite agnostic and to pick fields that leave open the room to describing models that are multimodal. So that can take in text or take in imagery or take in multidimensional arrays and output you know, different kinds of outputs.
Yeah, no, I mean that's cool. It's funny enough. My neighbor around the corner, he's a professor that does medical imaging, you know, and does machine learning research on that. And we were talking about basketball, and I mentioned the word foundational model, and we got kicking on that. But it's funny because they're pretty closely related when you get down to it, and finding some ways that those things can work together is great. Francis, I wanted to talk to you a little bit about some of the specifics within the machine learning model. What are with getting into the nitty gritty? What does it describe, and who's adopted it so far? Who's using it today?
Yeah, so I'll bring up my slides to provide support. Right. So initially, the idea of Stack MLM came from basically what was mentioned earlier. There was previous efforts that were done trying to provide it, but then there was limitation because it didn't support text with new LLMs being produced, or it was missing some key details about once I have my model, what is the runtime I need to run it, or many other details about what are the data source. You'll often find models that will say the input source was CMIP6 data for climate, or it was using Sentinel-2 imagery. But then you have no more detail than that. And that's a very large array of data that is involved in just these key names. So you need more relationship details about what are the items, what are the areas of interest, the times of interest. So all of this brought up together this stack MLM specification that was built upon the previous efforts and previous issues that were raised by the community. So we all the presenters that are here today, and also others that I've seen in the chat are here, that we all collaborated in the publication of a paper that goes into the very small details of which collection, which lesson learned, which previous extension and work were used to bring up the MLM, and that describes each of the properties in more detail. But today I'll show a very brief overview of the specification itself. So the general concept is to have a model card, so similar to what you'll find on Hugging Face, but with a bit more details. So not only providing specific fields on how to describe a model, but also guiding the users that want to describe their model about what might be relevant in describing their model. Not everyone is a specialist in every aspect of machine learning. So sometimes just having a hint that this field exists, maybe you want to describe this framework or this information, is already a great step in making them operational. This kind of aspect of MLM that is very important is that it builds upon existing stack and extensions. So rather than trying to implement everything, it relies on the existing infrastructure, the existing extension, and try to leverage them. The MLM is also very flexible. So one of the previous concerns that were raised in previous efforts in describing model is that there was limitation regarding which runtime can be described or which framework can be leveraged to run your model and reproduce the experiments. So these are also supported in MLM. And the last thing is, well, because we have a great community that involve different point of view on all to interact with model, we've been able to come up with different examples, and that will test it against various representations that are needed to ensure reproducibility. The core idea of Stack, as it was mentioned earlier and shown by Jed, is that you have an overall catalog that is then subdivided into collection, which are then subdivided into items. And for each of these areas of interest, you end up with different assets. So what MLM does essentially is that it considers the model itself as an asset that was trained for a given area of interest over a given collection of sample data. So it can essentially be described the same way. So that's the whole point of it. You start from your imagery of interest, you do any pre-processing data pipeline, data preparation that you need for fitting the model input. So this includes normalization, statistics, normalization, resizing, imagery, stacking different bands, reordering bands depending on the modalities that the models support, etc. And you end up with some kind of very complicated model input definition, which could be of different representation, imagery, text, whatever. Then you end up with a model that is trained at some point. So you have a certain architecture, you'll have the weights that are represented or a checkpoint, a specific framework that was used to train it so that you're able to rerun the code. You could have different exports. ONNX, for example, is a very common approach to export model and make them more interoperable. So these considerations are there. And then you have all the hyperparameters details that are describing essentially always the model obtained. So you're able to know exactly which one you're running with. Then you end up with the runtime assets. So any detail that you need for reproducing the training pipeline, reproducing the inference pipeline. If you have specific entry points in your model, which script to invoke, is it running on a Docker? Is it needing specific GPUs to run or TPUs or whichever other hardware that might be necessary? And then finally, you end up with the model outputs, which could itself also be variables. You could have imagery, classes, you could have segmentation details, just plain text describing what was seen on the imagery. So all of this is integrated into the machine learning model. So as I previously covered very briefly, the sections are separated into collections and then items. Each items represent a specific model. And within the item itself, you'll have the various assets. So the assets could be a different representation of the same model. For example, if you had a model that was trained on PyTorch, and then you're offering at the same time the corresponding representation with ONNX, you can provide them as well at the same time within the same model. So this increases the chance of reusability of your model because they are offered with different pipelines that could be supported by different platforms. You will have other additional metadata that are surrounding the model. So for example, if you have specific data sets that were used or specific approaches that are employed to tweak the model to ensure that it trained the way you wanted to obtain specific results, all the data provenance will be recorded in there. You'll have the details about everything was fitted into the model. And the representations of how the models are produced are following the stack best practice so that you can easily search them afterward. So once a model is using, for example, a certain framework, you're able to do a stack search query which targets specific models for a specific framework. And then you're able to retrieve whichever model you were interested in that match your criteria to rerun them on your specific platform. Obviously, there's a lot of metadata involved in all of this. It's very complicated. So to help in this process of describing a model, we've created a few tools. One is the Stack MLM form, which is essentially a UI, no code, that helps you fill in the data, and the JSON spec representing the MLM STAC is generated on the fly. There's also a stack model pydantic library, which is essentially helping you to integrate directly with PyStack or many other of the common tools that the community created over time for interacting with Stack. As I said previously, the MLM relies on previous efforts and extensions. So these are all the extensions that are involved in MLM, not necessarily a requirement, but they are strongly encouraged to be leveraged. So you'll have the labels and the classification extension, for example, that will help you describe the classes that are involved in the model. What is the model predicting? Where they're labeled, where are they located? You'll have the detail about the data splits. So which are your train, validate, and test splits for training the model. Any pre-processing that was involved in the model or any post-processing and data for data lineage is provided using the processing extension. There's a combination of raster, EO, and stack bands extension that are provided to represent which bands are going into the model. So sometimes you need more detail than just is it RGB? Is it RGB with near? Is it RGB with some custom mix of bands that is integrated? All of that is described using the bands extension or the corresponding ones with raster and EO. You can have stats and scientific extension to describe basically the statistic of the collection that were involved in training the model and which reference scientific work that can help you describe it even further. So if you need some specific additional details that are provided, or if you need to reference the public source of the model, it's provided through the scientific extension. And you can also provide your own scientific citation for publishing your model. So it facilitates reuse over time by the community. And then you have other various information such as file storage and versionings to ensuring that if you're iterating your process, doing multiple runs of retraining your model, evolving the model, you can keep track of that as well. So that is all for me. If you
Awesome.
need to contact me, you can find me on GitHub
Yep.
across all of these.
Perfect. So I think, I mean, that gives a really deep overview, and I appreciate kind of giving the context of who's using this, where we've gone, and all these different pieces. So I wanted to turn it over to Simone and talk about some real world use cases and get a sense of what this looks like, you know, quote unquote, in the real world. So I'd love to hear how you're using it, your experience so far, and kind of everything about how it's actually working.
Yes, thank you. Just gonna share the screen. Oh gosh, you asked me to quit and reopen. Are you, any one of you is able to share my slides? Please, sorry. Otherwise, it's asking me to reopen the Chrome.
Oh, yeah, I can totally share your slides, Simon, if you send them over. Also,
Yes,
if you need, if you do leave and rejoin like that, that's also another way if it's asking you to do that.
Okay, yeah, sorry, it's literally just, okay, let me, okay, maybe now it's fine. 1 second.
Oh, great.
There we go.
Is it working? Okay.
Yeah, we can see.
Yes.
Okay, excellent. Sorry about that.
All right. Good save.
All right, yeah, excellent save. All right. So you see the right. Sorry,
Yes, we see the initial slide.
Okay.
Yeah.
Okay, excellent. Thank you, and sorry again about this. So yes, I'm gonna be talking about how MLM extension has empowered AI and ML capabilities into the geohazard exploitation platform. So I'm going to give you again a quick overview about the company and on JEP, and then we start on the MLM. So Terradue is a company that was founded in 2006 by a researcher from the European Space Agency. We are a team of 18 people based in Rome from 5 nationalities. So our core business is supporting application builders in the context of earth sciences to create analysis-ready data and added value products directly from EO datasets. And we deploy and operate intensive data that are next to where the data is saved and without a cloud lock-in. So what about GEP? So the Geohazard Exploitation Platform is a cloud-based processing platform that supports natural disasters and has got more than 25 services focused on monitoring terrain motion and critical infrastructures. It's got a number of EO data missions, in situ data, as well as community-derived products. And a large community based on active users. It supports both systematic and event-triggered services that are also developed by external users that we help integrating them into the platform. And it can be accessed through a sponsored or direct purchase. So there are different ways in which a user can access the platform. So we have extended this platform with AI and ML capabilities, so to enable end-to-end ML ops. This included model development, tracking and evaluation, deployment of services into the platform itself, as well as automated testing, monitoring feedback loops for optimal model performance. And we are following the OGC standards and best practices for doing so. We have defined 3 service offerings, one for generating AI-ready data. One is the environment that the user can use for developing new AI ML models. And another one that is fully based on STAC, which is for cataloging data and models. Quick overview about the full life cycle of AI and ML workflow. We have the development environment that has got a point where the EO data is ingested, split into train, test, validate. There are all the model is trained and all the tests are done, and evaluation as well using MLflow. And then here is where the user can split into 2 different components. We have the training part and the inference part. Both of these can be Dockerized, and an application package is generated to make them independent, fully independent. And these can be then deployed into the JEP, the thematic platform. This interacts with Kubernetes for orchestrating all the different jobs and monitoring the jobs. And then the client obviously can interface with this platform for launching jobs, monitoring, and visualizing the results of existing services as well as their own services that they have integrated. Okay, so the development environment that I've been talking about has got a suite of number of tools. And they can be tailored to the specific needs in terms of resources. I'm talking about different RAMs, different CPUs. There is also GPU available for the user. A dedicated also interface for Stack browser is possible to be configured, both individually and as a team in a collaborative way. Then there is a remote desk for QGIS, so that everything can be shared on the cloud for the user, and a bunch of other tools like Jupyter Notebooks, Code Server, and MLflow dashboard for the evaluation and tracking part. Okay, we have identified a number of activities that are the usual activities for the ML developer. And I'm gonna be focusing on 2 ones that are related to MLM. But in the quick overview, activities are the ADA, labeling EO data, describing and discovering EO data using Stack, developing a new machine learning model, running a training job on a remote machine, describing a trained ML model using Stack MLM extension, reusing an existing pre-trained model, creating a training data set, and last one, discovering a model using the extension and invoking it on our exploitation platform. So The needs identified, some were covered already by my colleagues, but overall, with the MLM allows us to have a comprehensive metadata of my model, including all the relevant details related to the model input, the output, the architecture, the hyperparameters. There is a centralized resource management, meaning that all the information related to the model, meaning the training and the inference application packages, CWLs, the Docker images, and the model itself, for example, ONNX format, they are all within the same stack item, and allows as well to, through Stack API or Stack browser, to enable queries using these ML-specific fields to filter out the models I'm interested in, not just based on space and time, but also like using all the different properties. So related to the first activity related to the MLM extension, this is the describing part. So this was done through a Jupyter notebook, largely based on PyStack and the MLM extension, obviously, to add all the metadata and the specific assets that we needed for the model. Then the Stack objects were created and published into the S3 and the Stack catalog. The first article mentioned here is the one that Francis has presented before. There is another one that is more high level that we also have developed in the past. Here are some screenshots of the ML properties. On the left-hand side, you have all the MLM extensions related. Well, not all of them, just a few. You can see also the hyperparameters that were saved for this specific model. And on the top right, we have the assets. So in this case, we have the CWL application package for the training, for the inference, and the model in ONNX format itself, with some other properties of the model. And on the bottom right, we have a visual representation of how the model was published into the Stack browser. So once the model is published into the Stack browser, we can then use the filtering and querying functionalities via Python PyStack API to filter and discover the models that we are interested in. And this was also done through a Jupyter notebook, using PyStack and MLM extensions to filter out. Not just using space and time, but also some parameters of the model. Once I get the model I'm interested in, I can just then look at the asset and then, for example, finding out where the CWL package, application package is located. And here we have an example. On the left, we have a query that I used based on the collection ML models, date and time, and the spatial bounding box, but also some ML specific parameters. So I use a couple of hyperparameters and the architecture and the framework, just for a few examples. In this case, one model is retrieved, and from there I can look at the assets and then find out the href, so the path where the actual CWL file is saved. Once I have this, I can then deploy this CWL into an exploitation platform such as JEP. Here on the right, you see a number of services that were deployed with the same concept. And in this platform, the user can log in and play around and execute their jobs. Just to conclude the last slide, a couple of ideas for a solution for partnership. So we have this dedicated integration environment, which is fully cloud-based for ML applications, fully compliant and compatible with the MLM extension, to allow ML developers to incorporate DevOps practices into their own workflows. From the developing of the model, describing them with the stack, creating the application package, and then deploy them into the exploitation platform. Data discovery also fully based on Stack for the EO data sets. All of these solutions, the cloud solution, are all tailored to the user needs. So there are different cost models, different either pay as you go, as a subscription, or within a time frame. So it can really be customized depending on the user. And that was it as an overview of our practical experience.
Thank you. That was great. I mean, it's good to hear how this is actually happening, right? You know, and I think, like, you know, from all the elements that we've talked about so far, from starting with Stack as a specification, enabling better data access, even data discovery, into the MLM spec that extends that, allows you to build the models, and actually doing it, right? You know, to show the ability to kind of actually move through that was amazing. I know we're kind of coming up on time here, and I want to make sure there is time for questions. If you do have questions, feel free to start adding those to the chat. So we'll start addressing those. Ryan, I wanted to kick it back over to you. I think if you wanted to show like a short demo of like leveraging that within Wherobots and kind of how to do that with that platform, and then we'll kind of bring it all together and open up some discussion, and obviously encourage you all to participate. But yeah, that thing. Ryan, did you want to
I
do
do,
one more?
yeah. I think
Cool.
now I can share. Cool. So awesome. So yeah, how Wherobots uses the MLM is, you know, we support the development of it and making sure that it's a standard that can describe any model that you've trained and want to be able to search, discover, and run. And then we also provide Raster Inference. So it's a product where you can bring that description of your model in an MLM JSON, and you can upload that to your S3 bucket in Wherobots Cloud, reference it in SQL or Python, and then you're running batch inference with your model on your Stack data set of interest. So with this demo, you know, we're starting up our Wherobots runtime. We're loading some data from Sentinel-2 and check it out. You know, what are the paths we're going to be running inference on? We have this OutDB raster object, which includes a reference to the raster on S3, as well as all the raster metadata. And it includes a lot of functionality built into Wherobots to handle some very useful and commonly used operations when doing batch inference, such as tiling rasters into many small chips so that you can fit them into GPU memory when you're running inference. You can reproject rasters, you can do zonal statistics on them very efficiently. So this is the data type that we're working with here. And then we're passing in this table that references all the rasters that we want to run inference on to this function, the SQL function rs segment. And so rs segment can take 1 of 2 arguments. It can take either a path to your own machine learning model extension JSON on S3. This JSON includes a lot of the things that have already been talked about by Francis and Simone, including a reference to a model artifact that you are going to be using for inference. So currently we support PyTorch models in torch script format, and we're going to be adding new formats very soon. And so you can also pass in one of our hosted models that we've already prepared with the MLM JSON. So we're using MLM on our backend to make it really easy and simple to run hosted models that we've brought into our platform because they solve important challenges. In this case, we're bringing in a model from the Allen Institute for AI's SATLIS project. So this SATLIS foundational model has been fine-tuned to solve a variety of challenges like solar farm detection, wind farm detection, offshore platform detection. And so we brought these models into Wherobots so folks can try them out on their use cases. And so here we're just passing in the model ID to this, but you could imagine bringing in your own model JSON and running inference. And so you get your results. You know, we're running a segmentation model, so every pixel gets a confidence score. You can threshold that. and turn those thresholded pixel confidence scores into geometries. And so we're running RS segmented geoms on the results of our batch inference prediction. We see that we have a lot of empty results because a lot of satellite images aren't going to contain our feature of interest, but we see that there are some multi-polygons there. And so we're going to filter out all the empty results, and then we're going to see that we have our geometries that have an averaged confidence score. We're going to plot those, and then we can see some solar farms in our area of interest around Mexico and Arizona. And so that's how we're using the MLM in our product on Wherobots. Feel free to connect with me on LinkedIn or Twitter, or email Wherobots, or sign up for an account if you'd like to try that out. But you might be wondering, like, how do I actually describe my model with the MLM? So Simone showed that briefly that there's a Python API for doing so. And you can check out our documentation if you'd like to learn how to describe your model with the MLM. There's this open source Python package that Francis and I are maintaining called STAC Model, where you can validate your metadata used to describe your model. And you can then save out a JSON in Python after filling in all the metadata for each of these classes. There's also a UI I made that you can use if you want a no-code option to do this. So you can fill out metadata about your model, like satless, solar model, Arizona, and you can see that, like, the JSON getting filled in as you type. So the URL for this is MLM form Vercel app. It's linked on the MLM GitHub page. And it's pretty new, but we've been using it to describe the models that we're onboarding to our platform. It's just kind of nice to have a no-code option to do so. And it exposes a lot of the fields as kind of like helpful UI elements. So is your model accelerator constrained? Like, does it need to run on a GPU or a CPU? There's a lot of fields to fill in, and so it can be nice to have a no-code option. Yeah, I think that's it from me. Yeah, I'm running all this on Wherobots. So if you want to, like, try out this example yourself, feel free to sign up for an account. And we're happy to get you connected with the GPU Pro runtimes to do so. So yeah, connect with us if you're interested in that. Yeah, I'll throw it back to you, Matt, and yeah, eager to answer any audience questions.
Yeah, well, thank you, Ryan, and everybody for taking some time to chat and discuss this. I want to. I didn't see any specific questions yet, but feel free to drop those in as we discuss here. But I kind of wanted to at least bring it to, a conclusion point of what's the call to action? What should people do? Right. We talked a lot about why this is important, why this is good. What can everyone on this call start to do? And for people watching this in the future, what should they do? And this is open to anyone here to kind of answer and discuss.
Yeah, I would just say use the MLM if you have a model that you want to share with the world and you want people to actually use your model. Like, I think that's the key. Sharing weights for the model is good. Sharing the model artifacts, sharing papers is good. But providing, like, a clean standard description of what is required to search for your model and run your model is going to be really helpful to people people besides yourselves actually using your model in production. Great. And we got a question, I think.
Yeah, we got two questions here. So one was that there's one of the most popular ways to deliver deep learning models is safe tensor. Is there a possibility to add it as an artifact type? That was the first question here.
Yes, totally. Yeah, I love that you linked, like, where we would add that. I mean, that's an easy PR I can do, or Francis can do. And yeah, you bring up safe tensor. Like, safe tensor is like a really important format. Kind of guarantees that you're only executing model code rather than any arbitrary code that's been pickled out. So Yeah, totally. We can add that as a suggestion. And it's important to note that you can specify anything in the artifact type field. But we definitely want to like guide people along and be helpful and suggest like these popular artifact types.
Great. Second question, how do you see this working with model distribution platforms like Hugging Face? Is there a complementary spec for the training data sets? So I think kind of two questions there.
Yeah, for sure. I've been talking, so just if anyone wants to jump in, let me know. We're just but yeah, I think with Hugging Face, there's a couple ways it could work. Like Hugging Face could build an integration to the MLM and like surface MLM metadata in model cards if they wanted to have like a geo model card. I think that'd be amazing. How like you could reference models that are stored on Hugging Face in the MLM is you know, you can reference any you know, URL basically in the MLM spec, and Stack has a storage extension where you can provide more information about the storage provider, which can be helpful when accessing the model or fetching the model from these in remote storage environments. So I believe the storage extension describes like Azure Blob Storage, S3, Google Cloud Storage, and maybe Hugging Face is an option there that could be listed. Hopefully that answers your question. Does someone else want to comment on spec for training data sets in Stack?
It took me a second to get off mute. Yeah, I mean, we also had a label extension that Radiant Earth proposed a few years ago. It just gets very, very, very complicated. And so we have taken a step back from proposing these things ourselves, and sort of like I said before, see ourselves as more of a community facilitator. But Ryan, I do think that's something that somebody should take another swing at that. For figuring out how
Totally,
to,
and we
yeah.
might, yeah.
Okay.
I mean, I see a lot of like connections in like describing labels and models together. Like when you're describing the model classes, you probably want to discover the labels that were used to train the model if that was open, and you want
Right.
them to share the same class, you know, language. So that's just one example of where this would be really, really useful. You want the stack model to have references to a stack data set for the labels. You want it all to be linked. So totally, I agree it's complicated. And
Yeah,
I love the approach we've taken with the MLM. And yeah, Robin, if you or others are interested in the stack label extension, it's still up on GitHub. I believe it might even still be used by some organizations. And yeah, I think like hearing about interest in these extensions and it and raising that in GitHub discussions, GitHub issues, or the cloud native Geo Slack really helps you know, kind of give me ammunition to direct my time, my open source time, and doing development work on these extensions. So yeah, let us know if you're interested in this stuff. I think that would be a great spec to kind of revive and yeah.
Awesome. And there was a few more here. Generally, what type of satellite data is available in Stack? How frequent is it updated? And then anything specific about hyperspectral images?
Yeah, great question. So yeah, I know NASA and ESA are like, you know, big users of Stack to describe many of the data sets in their catalogs. So whether it's optical or radar, LiDAR, hyperspectral, I think it's all been described by Stack. Not every data set by like particularly every commercial provider is in Stack. But I think like, I don't know, for my like kind of narrow domain of like working with optical and radar data, like I've always found like a Stack data set to work with. Yeah, Jed, you have your hand raised.
I was going to say, yeah, I mean, Stack is sort of everywhere. There's no easy answer to this question. If you Google Planet State of Stack, Tim Schaub there in 2022, so it's old now, did like an inventory of all the stuff that's out there, and there's just like the adoption has been crazy. So sorry, there's no easy answer to your question. There's lots of data that's in Stack. It's updated at different frequencies depending on who's providing the data. So.
And sorry, just to add to that, it's a very dynamic world. So, for example, on the JEP platform that I just described, we have a lot of missions that we constantly update with new data according to the different projects. So, yeah, it's a really interesting world, but it can be customized and updated as needed. And just if I can say, it was mentioned to kept using and developing ML models just for the users out there. If you need any support in terms of resources, of course, like we are happy to provide some cloud environment. Just get in touch, and that's yeah, always happy to chat more over this.
Great. And I think the last one is before we just wrap here, because I know we're getting over time. Is there a way to describe the list of models in one JSON file?
So the approach for that would be to use the stack collection itself, which combines multiple stack items. So then you would have each of your individual model represented by one item, and then having the collection regrouping them all together. And then you can have as many collections. So if you want to regroup all your segmentation models together and then all your classification models together, then you just have two separate collections, but all the models within that are described with their own stack item.
Great. So I think that's everything we have for today. I mean, well, for everyone who's attended, thank you. We'll be sending some follow-up so you can actually get in, start working with all this stuff. Of course, tell your friends and make sure we're spreading the word about this. But I think it's been a good kickoff and kind of, I mean, I know we've been working on this for some time, but first of all, Jed, Simone, Francis, Ryan, thank you all for taking times out of your days to join this. And there'll be more coming your way, but once again, thank you. And we will be in touch soon. Thanks, everyone.
Thanks all.
Bye bye.
Bye, everyone.